Okay, so welcome everyone to this live session of the NPTEL course Measure Theoretic Probability 1. So if you are online and you can hear me, please post it in the chat box. So I already see a post by Himanshu. Again, good afternoon to you, Himanshu. There might be a slight delay in the stream and the chat box. So please be aware of that. There might be a slight delay of 30 seconds or so. So again, good afternoon, everyone. So maybe I'll start by quickly introducing myself. So I am Suprio Bhar, faculty in the Department of Mathematics and Statistics at IIT-Kanpur, Indian Institute of Technology, Kanpur, India. So again, just to give you a quick overview, so my major interest is in theoretical probability, and this measure theoretic probability is one of the main backbones of whatever I do in my own research. So again, I'm sure that you might be enjoying the course. So please let me know about your doubts, or if you wish to introduce yourself, that is also welcome. So please also let me know about your backgrounds, what kind of things you expect from this course, and so on. So hello everyone. So again, I have posted a message in the chat box. So please let me know if my voice in the stream is clear. Okay. Okay, so I would request the participants to introduce themselves if possible. Okay, so I see a question from the chat box, a question in the chat box from Himanshu. So what are the central questions that one deals with in theoretical probability? So I'll tell you what I do. Theoretical probability is quite a large subject. So one thing that you will definitely need is in the practical life, many of the natural phenomena that you see in nature includes randomness, and for the study or modeling of such phenomena you need theoretical probability. One other thing that you should be aware of is that once you model it, you are also interested in these statistical features such as obtaining means and variances and stuff like that, or you might be studying certain evolution patterns of certain evolving systems. So once you are looking at such problems, then a theoretical background from probability side is very much required, very much necessary. So what you typically would do is to look at how the system is evolving. So there is a rate of change coming in. If you are looking at from the discrete time perspective, you will be having a sequence of random variables indexed by the time points. If you are looking at a continuous time framework, if you are observing the phenomena in continuous time, you would get what is known as stochastic process in continuous time. So now what I am mostly interested in is evolution in continuous time, where you get this rate of change coming in. So there is this kind of a merging of theoretical probability and differential equation. So differential equation is purely because you want to know the rate of change in time. So with this common line between these two areas, I work in something called stochastic partial differential equations. In other general areas, you are interested in this. If in the discrete setting, for example, you are interested in large time behavior of such models. You would like to know, if you are studying certain models, what is the large time behavior, what happens at the end. So even if you cannot observe it, what can you say to be happening to the system at the end? So that's what are certain central questions that you might deal with in theoretical probability. So yeah, so if you have more specific questions you want to ask, please feel free to post the question. Any other questions, comments? Himanshu, you might also let me know if your question is answered or if you need more details. Okay, great. Thanks. Thanks for the response. Okay. Okay, so again, request to the participants, maybe you could take this chance to introduce yourself, and you can let us know about your background, what you might be expecting from this course. Again, I request the participants to post about themselves, what you might expect from this course. Please do that. Yeah, great. So thanks for the response. So again, thanks for the response, Himanshu. If you are interested in Brownian motion, so that will be the motion of a particle in a homogeneous medium, and so that's what exactly Brownian motion is all about. So motion of a particle in a homogeneous medium, and what you get at the end, if you add heterogeneity to the medium, you get something called the stochastic differential equation, which expresses the motion of the particle in that heterogeneous medium. So that's a slight generalization of Brownian motion. So I'm sure that once you do this course, you would have some more basic idea about what measurability means and what kind of adaptedness, the so-called term adaptedness is required for the study of such processes. Yes, so Brownian motion is definitely one of the very, very important processes that you require in continuous time. So it is the natural object for processes. If you want to compare it, in the case of random variables, the natural object is in some sense the Gaussian distribution. So in the case of continuous time stochastic processes, it will be the Brownian motion. Yes, so I am sure that you will enjoy doing it. If you enjoy doing it, you will definitely learn nice things about it. Anyone else wants to join in? Please introduce yourself. Please let us know what you expect from this course. Okay, so since I'll wait for you to respond, so I think this will be a good time to mention some of the background or make a consolidated statement about what we are doing in this course. So that might be a good thing to do right now. So one thing that we can definitely think about it is that since 4 weeks are already over, what did we learn? So what we are learning here is that how to structure randomness from this mathematical viewpoint. And we have first of all looked at these random experiments, looked at the corresponding measurable structures that appear from this collection of events. And then once we get the events, we wanted to see whether which events are more important than compared to other events. So that led us to this idea of measuring sets, giving certain values to these sets, which gives us these probabilities. So we formulated the probabilities, but then there was also this notion of random variables that appears as functions defined on these kind of function spaces or this kind of measurable spaces. So then putting them together, we ended up with this law of random variable, which appeared to be a probability measure. And then we recovered all these usual properties that we have studied from basic probability, such as the properties of this distribution function. And then towards the end of the fourth week, we have been explicitly discussing the connection between the distribution functions and the corresponding probability measures. And in particular, we have also discussed the correspondence between random variables and probability measures. And what we are going to see from now on is that there will be an explicit construction of certain integration structures, which will be in terms of the corresponding probability measures, the laws, and you can express everything in terms of the laws. So whatever you have studied in your basic probability in terms of the discrete random variables and in terms of the absolutely continuous random variables, that was discussed separately. Now we are doing it under one big umbrella. And then you will also see that the usual integration theory that you do in real analysis, that will also fall under the same umbrella. So measure theory has this power, measure theoretic integration has this power to kind of cover all these details under one single umbrella. So that's one of the very nice advantages here, is that if you get a general result, you can apply it to all these settings that you need. So that's what, in a nutshell, what we have been doing and what we expect to have in near future. So let us see what we can go about in this course for the next part of the course, so in the next 4 weeks or so. All right, so I think there is a comment from Himanshu again, so let's read that out. In physics, in statistical mechanics, people study Brownian motion, and in mathematics, also analysis on Brownian motion comes. So is there any difference in the analysis of Brownian motion? No, I would put it this way. In when you are studying this more measure theoretic viewpoint, you are mostly interested in the underlying measures or laws that appear, and then you try to make probabilistic statements. In physics or statistical mechanics, you are more interested in the, I would say, the moments or joint moments of such random variables that appear in your process. So in statistical mechanics, the problems will be more quantitative in nature, where you will express all of this in terms of these covariances, certain moments, and things like that, long-term dependence and things like that. But here in mathematics, what you will expect is a more theoretical study regarding existence properties or path properties of Brownian motion, certain growth bounds that are given for Brownian motions, and things like that. So that's what will be important in when you do this mathematical study in detail. So if you want more details, please post it in the chat box. I am happy to answer the question. Okay, so maybe let us wait a couple of more minutes if there are any questions. I'm sure that all of you are using the forum and discussing things. So I have seen a couple of students who are quite active. So I'm happy to be in touch and be in the discussion, talking about or communicating through the forum. So in any kind of a doubt, please use the Google forum. So we can of course discuss there. But this is a chance for us in the live session to have more of a face-to-face kind of a meeting or discussion. I mean, of course, you have to post the question in the chat box, but this is just another medium where you might be more comfortable. Yes, thanks, Shimanshu. I have just seen your chat. I have just seen your post in the chat box that you are going to type a question. Please, I'll wait. Please post your question. Anyone else wants to add something as we wait for Himanshu to post his question? Okay, so I see your question in the chat box, Himanshu. I'm checking it out. So you are reading a paper on Brownian motion from numerical technique point of view. You are plotting the graph, okay? So you are looking at the mean square displacement, okay? Mean is taken with respect to time, okay? Yes, please continue. Okay, so MSD is mean square displacement. I guess that's what it is. So it's time averaging of displacement over different intervals. So why it is used in plotting trajectory of article with respect to time. So I feel that maybe it would be plotting trajectory of the particle instead of particle. So that's fine. I think I get your question. So you are asking about the mean square displacement of time averaging displacement over different intervals. So I'm not really sure about the question because I haven't seen this issue before. So what I understand from your question is more about the mean square displacement, and maybe your doubt is regarding the why. I mean, it could be possibly related to the question why mean square, why not mean displacement. So is that your question? Can you please clarify? Okay, so I think I understand the second question which you have just posted. So I'm still not clear about the doubt in mean square displacement related thing. Of course, this is out of the course contents that we are discussing, but I am happy to discuss about that. If you clarify your question a bit more, whether your doubt is in mean square displacement versus mean displacement. So maybe that would be one clarification you might let me know. But the second question is you are looking for the time averaging and ensemble averaging. Yeah, this is a very important point. So time averaging refers to the issue when you are focusing more on the time behavior of the thing. So you are looking at the paths, different paths that you see in Brownian motion. So you are averaging it in time, right? But ensemble averaging will be the focus more towards the values. So it's more of a spatial averages. So that's what it is. So in a short time frame, if you are looking at the time averaging viewpoint, then you are just looking at the idea about the displacement of the particle in time. But ensemble averaging is more of a large time behavior or more of a limiting behavior of the system that you are tracking. So here the system is location of the particle in a large time setup. I'm not sure if that answered your question. So could you let me know if this is exactly what you are asking about? Okay, so I see your latest post that your doubt is regarding the mean squared displacement, that it is the time averaging of the square of displacements over different time intervals. So, unfortunately, I am not really able to follow what exactly is the doubt. So, definitely one thing that we can try is to pick up this discussion in the discussion forum where you can actually post about the this exact paper that you are reading about and why you are not using ensemble averaging. The reason could be simply being mentioned in the introduction of the appropriate paper. So maybe it will be a better idea to take that discussion in a more detailed setting in the forum. So you can also mention the reference in the meaning that papers that you are reading, and maybe the techniques that are being used. So I'll have to see that paper to maybe properly follow about your doubt. So I'm sorry, but I'm unable to follow your exact question right now. So it will be better if you can mention about the exact paper and we can take up this discussion in the forum in a more detailed fashion. Yeah, okay, thanks. Thanks for the thanks. Okay, so all right. So any further questions or doubts, anything the participants would like to discuss? So maybe we'll wait another couple of minutes for any further questions. Okay, so we'll just wait 1 more minute and maybe end the session if there are no further questions. Okay, then, so I think this is a good time to wrap up the live session. So again, if you have any questions that you come up with, or if there are any doubts regarding the course materials, please go to the Google forum and post your question. So again, goodbye all. So please join us again if there is a live session scheduled later on. Okay, goodbye everyone.